honestly. I hate myself, you know. I hate myself. And I'm just a bitch. That's all I can say. Just all the time. And I cannot focus on my work. It's fucking hate you. Shut up. Alright, what do I want to say? So my problem is this. I don't even want to cascade. Position bias model. One. Position bias model. I don't want to talk about cascade model. It just makes it complicated. Bias model. So probability of clicking on one item equals, or purchasing it equals probability of observation times probability of relatability, right? And probability of observation and probability probability of observation, for example, is independent, given, and we have two types of products. We have k types of products, and so what we know is that we have a list of n items, and we have another list n items, and we assume probability of observation is fixed, yeah, for each list, and it is given. We know them. Alright. So we have type 1 product and we have type 2 product, and we have n of them, and we have two types of users, by the way. Two types of users. Two types of users. Type 1 user is wants product 1, v equals 1. Type 2, it's v equals 2. Alright. So now we want to say probability of relatability of item from group 1. We also have this as a probability of relatability equals 1 given group 1, which is what? Given type equals 1, and so we have items in group 1 are called A1, and A2 is group A2, and R equal 1 given A1 and V equals 1, and item I f of item I. So what is A1? A1 equals A1. Alright, so group 1 is A, group 2 is B, and A equals A1 to AN. I'm feeling better now. Okay. I mean, there is no point trying to shutting that fucking voice in yourself down. Just focus on other voices. Give them attention. B1. Let's just say BN. I mean, you cannot totally ignore it, by the way. But it cannot disrupt all your work and all your day. It has its own time and you need to deal with it. Fucking finish your PhD. So A1 to AN and B is B1 to BN, and we want to come up with a pi from A union B to 1 to 2n, right? Which is C actually. And A and B are mutually, they're disjoint, they're mutually separate. No, they're separate. And okay, now probability of, we also know that probability of R equal 1 given V equal 1 and C in A, we have that given. Probability of R equal 1 given V okay, let's say V equal A or whatever. V equal B and C in A is 0. Probability of R equal 1 given VA C in B 0. Probability of R equal 1 V equal B C in B also given from our other experience with the list of n. Now we wanna come up with the best shit here. So we wanna maximize DCGR probably sigma P of R equal 1. Oh, okay. Also, I am assuming probability of V equal A is given and probability of V equal B is given. For example, V equal A is 2/3, V equal B is 1/3. And by the way, I bought a microphone. I need to bring it and add it. So this is it. V equal A, V equal B, 1/3, 2/3, and 2/3, and now what we want to maximize is giving a pi that probability of click. What is the probability of click? relatable, observable, right? For the click, I want to end maximize is to end probability of observability at position I, probability of relatability at position I, which is probability of yeah, I didn't use cascade model. I think this is simplest. We should start with the simplest, and fucking cascade is extra complexity unless we don't need it, unless if it is necessary, we don't want to add it. So probability of observation, it is given. We can say probability of observation given I depends on the type of the consumer. I assume it's just assume it does not depend on V. Probability of relatability is probability of R V equal A I plus probability of R V equal B at position I. It will be I1 to 2n probability of O equal I probability of R and B, R V equal A given position I doesn't depend on the position I, by the way. It's just probability of R V equal A is probability of V equal A times probability of R equal 1 given V equal A. So it is probability of V equal A and probability of R equal 1. Okay, now this depends. What is that? Item I in 1 to 2n. F of I already computed those shits. Okay, this. So now, fucking elbow and probability of V equal B, probability of R1 given V equal B, something like that. And so what do I have equal aims? and probability of O I probability of V equal A of R1 F of pi I It's the same thing. Alright, now the two other we wanna be B given B equal B. Alright. Now I wanna say this is I equals 1 to 2n probability of O given I. So probability of R equal 1 given the item belongs to category A and also given the user is in category A is that is deterministic, right? Probability of R equal 1 and F in A given V equals A is probability of R equal 1 given V equal A and F in A times probability of F in A given V. Well, that part is just deterministic, so we can say they are equal. V E probability of F R equal 1 VA F in A. The other one, F in B, deterministic, but probability of F in B given V is in A. Alright, no, probability of relatability given the item is in category B and the user is in type A, it is 0. That's it. And plus probability of, oh, okay. Yeah. B equals B. Probability of V equal B, probability of R equal 1 given V equals B and F in B. And pi shows itself in F. I want to share this with you. So now we want to optimize over pi. What is the best pi? Optimal pi. And we have that. Oh, by the way, these are given. Probability of R equal 1 given V in A and F in A is given. So that's kind of, that defines what we should do. We have this one. This one is given. This one is given. This one is given. This one is given. This one is not. Everything is given. Well, the pi depends on F, and how would I choose? If it is 2/3, how can I sort those items, right? Probability of relatability for one list. So what we sort, how we sort is we compute probability of V equal A times probability of relatability of the item, which is very intuitive, and we sort arc sort of this. Well, that's so simple. That was nothing in it. That's so if you have the probability of relatability from specific maybe that's why we don't want to have this position bias model, because this way it says, alright, even every object will be seen, everything works fine. I think Cascade model helps. So the new relatability is your old relatability times the probability of user's type. Now if we have a user from type A coming to this platform, let's just yes, that's actually an interesting question. Now let's keep it the same thing. Let's keep it I don't have my charger. Now user A vehicle A comes on the platform, or vehicle B comes on the platform and searches the broad query, right? Searches the broad query. How much do you lose? So let's go with example. So let's assume it is 1 over log for category A, log I. So, like, oh, okay. That is just probability of observation. Yeah, proportional to 1 over log. Let me get. So you want to see how much it drops. What is the price? What is how much it drops? Like, right? You want to see what is the difference? How much this mixing this stuff changes everything. So that's the thing. I cannot compare two lists with position bias model. Do you know what I'm saying? It's like you have probability of observation, which they do not sum to 1, like for different lists, for different it just says this is the probability of observation of item this at this time, and probability of getting a click in general. So if I want to save, I should say probability of getting a click in total is probability of getting a click, probability of getting at least 1 click, C greater than equal 1 equals sigma I equal 1 to n 2n, probability of C I equal 1 well, actually it doesn't say that. Is that it? In position bias model, do we say that probability of observing getting a click at position I is independent of getting a... That's why Cascade model is nice, you know? because it says it relates the list as a whole thing together. In the position bias model, we don't treat the list as a list. We just say each item gets so if I have mu1, dude, this guy missed FaceTime call. Who is she? That's, yeah. Cascade model approaches a list as it is a list. Position bias model doesn't approach a list as it is a list. And it's just more. It doesn't give me joint distribution over clicking on different items on the list, different positions on the list. Alright, so I want to say and the model lets people to click on multiple items. So right, CI well one. So that's the problem with position bias model. PBS let us click on multiple PBS let us click on multiple items. Fuck off. Okay, PBS let us click on multiple items, which is not true, which is not something we want, and we want Cascade model instead says that okay, we only can click on one item. Are they independent? We can still keep using PBS as long as we come up with an idea on how to weave these probabilities over each position together. So if I say, what is the probability of getting a click at position I and J, right? 0, is it? Or is it like probability of getting click at I times probability of getting click at J? If I say they are independent, it's fine too. Just we need to come up with a joint strategy. And for sure IJK, we're getting click at position I and J equals. And if we are saying probability of getting click at position I and J is 0, we should say, okay, because probability of relatability can change for position I and J because we can come up with different items at different positions and we can change the ranking. but probability of observation is fixed. So we need to come up with assumptions on probability of observation. Do we mean that probability of O equal I and J is 0? We just choose one. This means sigma probability of O equal I1 to n is 1 or less than 1, and there is a probability of exit maybe, but let's say there, that's it. And which leads to a kind of a cascade model, to be honest. So I say now we have reasons to go for cascade. And what was the cascade model? I looked at it yesterday. So position bias model is very simple. Fuck it, I'm gonna keep it like this. I wanna know what is wrong with this problem. I can assume that they sum to 1, and we will throw away the resting n. Alright, we will keep n of them and we will throw away the other n. And so we are assuming it's a position bias model. We are gonna click on one thing, and we only can click on one thing. Or we don't click. Alright. So if you want to maximize the probability of getting click, and then if you want to get maximize probability of revenue is sigma pi probability of C equal I, right? And P of pi I. That definitely just sorts based on that. Expensive. So let's assume we can all have all of those shit. Oh. Okay, I don't know how to bring updating rule. If you want to talk about fairness, if you want to talk about flooding, anything like that, that's the question. And we need to, if you want to talk about how to bring the update rule, we need to go back to our first system and say how did we come up with the initial P of O at the first place. And what was my other writings last session? And then I want to say, if you don't have any of those, how can one thing, okay, you find categories, and how can yeah, I think that is this. How can we find categories and in a broad list? And that's a good one. The other thing is, even offline data, I think that's it. Either we have broad query. What are our main questions? broad queries, fairness. How important is it? I think fairness is not important all the time. We don't need to be fair all the time. Fair. And the other one was multi-touch. The other one was alright, but let's go with this one. I don't wanna distract the topic. Let's give it one topic. And the other problem was the ranker one, which was super interesting as well. But the ranker one is just it's just about ranking. It's not about broad queries. It's not about fairness or diversity, and it's not about multi-touch attributes. So it's just a interesting thing to have in mind. That what happens if you have a wrong ranker. Yeah, because if we want to improve a list, we need to have exactly. That's why position bias model has problem. Position bias model, I mean the one that I find out, does not give a score to a list. It just gives scores to positions. But the cascade model can actually give a score to a list. So position bias model, at the end of the day, today also I turned my position bias model into a cascade model, which is not exactly a cascade model. But the point is that you should come up with a joint probability distribution that says, all right, with what odds the user goes to position 1, to position 2, position 3. Position bias model has this, but it doesn't say if it goes to 1, is it possible to go to 2 or no. It doesn't say joint probability distribution, that position 1 and 2 being seen at the same time. I assumed it is 0 at the right now, but we can come up with a cascade model. So I think cascade model or something like cascade model, what we really want is a joint probability distribution over all items. And cascade models give it a simple, because that space is very big, we are coming up with a probability distribution over observing all these positions, right? So it's not about clicking actually, because clicking depends on observation and relatability. Relatability of each position can change because we can change the ranking, but observation, we assume it is fixed. Cascade model says we start from the top with probably this, we see this, if it is relatable. If not, we go to the lower one, we go to the lower. Today I assume very much more simpler, we only go to one of these positions. I think Cascade is a good model, the most natural one, that gives us a joint probability distribution over observation. But to be honest, we can have any joint probability distribution on observation can work. But that space is super big and we don't want to work with those distributions. So what is that space exactly? That space is like you are saying, what is the probability of me seeing any subset of 1 to n, which is 2 to the power of n elements, and you need to come up with a probability for each one of them. Well, 2 to the power of n, yeah, exactly, and empty set stands for exiting and not seeing anything. So you come up with all of those, and that works. If you have that probability of observing a subset, for each subset, it's amazing. Cascade model gives you a probability of observing any subset, but it works on a much smaller classes of subsets, only ones that we start from the top and go down and may stop at some place. That's it. So it's like 1, 2, 1, 2, 3, 1. So cascade model actually comes out, that's what it is. Catch hate from my classmates. Cascade model says probability of observation of a lot of subsets are 0. We only have probability of observation of, instead of having 2 to the n subset, we only here have like n or n plus 1, not seeing anything, seeing 1, seeing 1, 2, seeing 1, 2, 3, seeing 1, 2, n. That's it. That's the beauty of cascade model. That was a nice talk. Okay. Let's see. Do I want to stop here? I guess we are good. Yeah. Cascade model is very nice. Well, this position bias model I gave is also nice. And that like generalize the space. That can be also too much. Nobody goes to position n and position n over 2. These odds are 0 as well. That's why cascade model is so natural. It's good assumption to have. The only thing is that it's probably more complicated than this extended or. So here what I am saying is that probability of observation of item 1 and 2 is 0 together. We only observe one item, which is very unnatural. However, it may be simpler. So anyways, everything is fine. Everything is fine. I think we can move everything to a natural cascade model, and it works perfectly fine. And what is a cascade model? I think it's not very difficult. You have just a probability of observing item 1, probability of observing item 2 is, or probability of observing subset 1 and 2 is probability of observe 1, not relatable, probability of observe 1, not relatable, with a mu 2 1, I move from 1 to 2. And probability of what is observing number 3 is I go to 1, not relatable, 2, not relatable, and mu 3 to 2, I come to 3, or I will exit. So this is not very complicated. Just for now, we can keep the mathematics simple. Yes, that was the problem with position bias model. It didn't give us a score for the whole list. It was giving a score for each individual position, which is not good. Alright, I'm good now. Thank you. Look at me. Every time I come here, I get happier. That's the purpose of life. Some people say happiness is not purpose of life. Fuck them.